Domain and range. So you should have had plenty of practice last lesson substituting values in, yes? You're happy with that now? So talking about domain and range, these two words, for some reason people get a little bit stressed about this aspect. Hopefully you won't. Essentially, domain are the input values for the x values. So if we're asking about the domain of a function, it's the input values, in other words, the x values. And what we're saying is that either you are told which values to use for your domain, or they may say, are there any values that you cannot substitute into this function? And we'll talk about that a little bit later on. So if the domain is our input values, or our x values, what do we think the range might be? Output values or the y values, yeah? Okay, so domain, range. X and Y are alphabetical, so are domain and range. Okay, so the domain comes first, that's your x values. Your output are your y. Discrete domain and ranges can be shown on a mapping diagram. Discrete means that they are individual. Do you remember when you were learning about statistics, about discrete data? It's separate numbers. And so you have one sibling or two siblings or no siblings. You don't have 1.27 siblings. Okay, so that's discrete. So if you have discrete domains and ranges, you can show them on a mapping diagram. These don't come up very often, but just in case they do, we need to just make you aware of them. So a mapping diagram essentially has two circles-ish, ovals. In one side there will be a domain, and on the other side there will be your range. Okay. They then will have a rule. So here we can see my function is x plus 6. And then they will have an arrow going from the value in the domain to the value in the range. Okay? Really straightforward. Sometimes there may be one value in your domain goes to two different values in your range, or vice versa. Okay? So domain, in this case, is what? How would I list my domain? What values are in the domain? Yes, not true. What values are in my range? Yeah. Now, these squiggly brackets here is set notation. We haven't done sets. Have we done sets? No, okay. So don't stress too much about it. We'll come on to this later. But so this just listed the values are in there. Okay. Here's a kind of example of a question. The function gx equals 12 over x has domain 1, 2, 3, and 4. Find the range. How many do you have? Well, my domain, they told me, we just need to know the range. How are we going to find the range? You've got the right idea, I think you said it incorrectly. 12 divided by 10. Yes. So you're going to take each of those numbers separately, yes? And you're going to divide, you're going to do 12 divided by each of those numbers. So we're going to work out what 12 divided by 1 is. We're going to work out what 12 divided by 2 is, 12 divided by 3, and 12 divided by 4. And then we're going to list those as our range. Okay, so what's 12 divided by 1? 2, 3, 4, 4. That's really weird. Okay, so normally we would list our range in numerical order. So 3, 4, 6, and 12. Pretty straightforward, yes? Okay, so you just had to, if you read that question, you would just have to understand what is the domain and what is the range. Function fx equals x squared plus 6 has domain all real numbers. Find the range. Okay, so this is a little bit trickier in that they're saying that we can put any number. Any number can go into this function. So we need to know what numbers would we have as our output. We haven't looked at quadratic graphs, have we? Okay, so let's do this a different way. So let's pick a number, any number, and stick it into here. So f2. Okay, what's 2 squared? 4 plus 6. Okay, and find another number, maybe a negative number. I had 6 louder. So we go negative 6 squared plus 6. 42. What could be another good option to have? Remember when we were drawing straight line graphs, what do we often substitute in to a little bit more information? No, it's not very good. How about what if x is 0? Yes. What's f of 0? Okay, because it would be 0 squared plus 6, yes? So we've had a positive number, we've had a negative number, and we've had 0. Do you think there's going to be anything that we can say about the value of this function or the numbers that we would be getting here? They're all positive. They definitely look all positive, yes? Do we think there's anything else that we might be able to notice? Hang on, Jodie, what did you say? It starts at 6. So Jodie's suggesting that because f of 0 is 6, that these numbers are all going to be more than 6. Is that what you're suggesting? Well, let's see if we can find a value that might be the exception to that. So we had negative 6, we had 2. Any ideas? Probably a number around 0 might give us one less than it. Anyone want to suggest something? 1 or negative 1? Okay. So what's negative 1? So what negative 1 squared plus 6? Yeah, it's 7. Okay, there's 1. 1 squared plus 6. So Jodie's suggestions are quite good at the moment, isn't it? Yeah. And I will tell you that she's actually correct. Okay? So our range for our function is that our values have to be greater than or equal to 6. Okay, we may want to say y. Our range y is greater than or equal to 6. You're comfortable with the greater than or equal to sign? Yes? So, y is greater than or equal to. So this here is larger at the y, so it says y is greater than. If we had said y is less than or equal to, it's because this tiny bit is next to the letter. Yeah. So y is greater than or equal to 6. And we would have a range for our range, because it's not a discrete set of data. Okay, so this one here, there were just literally 4 numbers in our domain, so we had specific numbers in our range. For this one, they gave us said any real number. So here we're going to have a range of values. Okay. Now, we've shown on the graph, domain is the x values and the range of the y values, as we've said. This is where your graphical calculators come in useful. So if you were to input this function here into your calculators, you would get a diagram that looks like this. Now, sometimes they may actually give you the diagram as well. Okay, so they may not just give you the equation, or they may just give you the diagram and not tell you what the function is itself. Looking at this diagram here, and for a lot of the questions, if it's a graph, then a lot of the questions will have this as their domain, and we would say that x can be any real number. The only times that you really will have specific numbers is if it is a list or a mapping diagram like the one before. Okay? If it's a diagram like this, 99% of the time you will have domain can be any real number. Our range. So we need to look at our graph here. So can we see anything specific about the location of our graph? So this is where our graph sits. What about the values? Remember our y values. So we're looking at the values that it can take along this axis. Can we see that the values of y have to be greater than or equal to 1? Because the graph sits above and touches the 1. Yes? Do we appreciate that it can be any real number? There's no gaps in the graph, there's no breaks, it's very smooth, and we know that this graph can carry on and on and on forever. So that's why the x is any real number and the range is greater than 1. Okay, so that's from that diagram. This is where it starts to get a little bit trickier, in that in some cases they may say which value is excluded from your domain. There are two main reasons that numbers would be excluded. It's impossible to divide by 0 is one reason, and you cannot square root a negative number is your second reason. So if your function has any kind of fraction involved where the letter is on the bottom, then they may be looking at this feature. If you can see any square root signs, then we would be looking at this feature. So I'm looking at this function here. Fx equals 1 over x minus 2. I can see that there's a fraction involved and x is on the bottom. So that rings bells in my head to say, okay, hang on a minute, there's going to be some exclusion going on here. The exclusion happens because I know the denominator cannot equal 0. Because if you try anything in your calculator and divide it by 0, it will tell you it's mathematical error. So I know that x minus 2 cannot equal 0. That follows that x cannot equal 2. You all happy with that statement? Anyone sitting there thinking, what on earth is showing that? Maybe because you came in an extra 5 minutes late or whatever. What you know, I'm going to do you understand the fact that you cannot divide something by 0? Yes? So that means that if you cannot divide something by 0, the one situation that we're looking at is when what would make this 0. So if the value of x was 2, this would be 1 over 2 minus 2. Or what's 2 take away 2? Yeah. And that's what we said we cannot have. And so this value here cannot be equal to 2. This value here can be 2.000001. Okay? It can be 1.999999999. It can be anything either side of it, but it cannot equal 2. You happy with that? Yes? So there's only one situation here that we need to exclude, and so what we would say is that the domain is any real number. This fancy phrase here means any real number. And then we have to add this specific statement, cannot, but x cannot equal 2. Now, if you're looking at this and these symbols thinking, no, where am I going to remember that? That's fine, you can use words. So you can say it can be any real number, but cannot equal 2. So when we come into sets of Venn diagrams, it's literally like a C with so it's a curly E, and then the R just has a double. It's a capital R with a double line. So I know it's got fancier things there, but you're not supposed to. Okay. Similar situation here. I can see that I've got another fraction involved here. Now I should add. And I'm going to change this function. I'm going to say x plus 1 on the top. Instead of just 1, I'm going to change it to say x plus 1. Because I want to make sure that you appreciate that when we talk about these situations, we do not care what goes on the top. Okay, so it really doesn't matter what's on the top. The only thing when we're talking about domains and ranges, or domains, is what's on the bottom. Okay, so it's this feature here that cannot equal 0. So in a similar way that we did at the top, we would say that 2x plus 3 cannot equal 0. So 2x cannot equal negative 3. X cannot equal negative 3 over 2. Now, the more you do of these, the more hopefully you'll start to recognize. Remember when we were factorizing quadratics? And we had 2 brackets? And we were trying to show the values that it was equal to 0? Does anyone remember that? Yes? So remember, it's the opposite value to this over this over here. So, the value we need to exclude is negative 3 over 2. And so our domain for this one would be, again, any real number, but not including negative 3 over 2. In words?
Oh, like, is it ER not 2?
Yeah, X, ER, X cannot equal negative 3 over 2. So it can be any number apart from negative 1.5. Okay, and again, it could be negative 1.49999. It just cannot be negative 1.5. 3 over 2 is 1.5. That's not, I understand what you're saying.
No, I understand. I was just wondering why it's ER.
Oh, so this just means is a member of, and R represents any real number. Okay, there are other codes. We have Z, represents an integer. Do you remember what an integer is? What is an integer? Whole number, yeah. We have Z plus, positive whole numbers. We have Z minus, Z minus would be negative integers. And we have Q, which are rational numbers. We'll go into this a little bit later, but don't stress too much about it. R is the most popular one that you would see. Okay, and then talk about any number. And for this one here, we can see a square root. So immediately we need to appreciate that we cannot go into the negatives for square roots. If you tried on your calculator to take the square root of a negative number, it would again tell you mathematical error. So here our domain has to be greater than or equal to 0. Okay? And this has just been reversed from up above. So x has to be greater than or equal to 0, be any real number. And this is actually telling us that y is greater than or equal to 0, so this, for some reason, I included the range for this one as well. Okay? And the only thing I can suggest is once we've gone through these, just the more you practice, the more you start to get into it. I'm not going to labour on the point. We're going to work on it today, and then I'm not going to work on it for 6 days to make sure that you fully understand it, because it doesn't always come up. It's just one of those aspects that hopefully it's clicked. If it hasn't, I wouldn't stress too much about it. It might be 1 mark that you would do. So I did this is equal to 0. So I looked at my denominator. And that's why I wanted to change my question, because I want to make it clear that it doesn't matter what's on the top. We just focus on what's on the denominator. So the denominator happens to be 2x plus 3. So what you do is you put that value, that expression is equal to 0. It says it cannot equal 0. And rearrange and solve it. Yeah?
We would never rearrange the whole fraction.
No, just the denominator.
What do you mean trying to
We're trying to find which value would we have to exclude from our domain. So what that means is, I keep telling you that if you were to put some of these values in, and you would get mathematical error on your calculator. Okay? So we're trying to find which numbers would give you that mathematical error message on your calculator. So we are establishing the fact that this denominator cannot equal 0, because that is the situation that would give us error on our calculators. So we're trying to establish which value does that. Am I not saying it very well?
Like, is this like a question?
Yes, so they would say, like, here, state the values of x that must be excluded from the domain. So that's the kind of question that would come up. So if that came up for this example here, state the values that must be excluded, we would say x equals 2 would be excluded, because it cannot equal 2. Sometimes the wording of it, you just have to be careful. So if it says which must be excluded, you would identify 2 as being excluded. Do we understand that? Because x cannot equal 2. Yes? I'm getting, I don't know if I'm... Does that help? So here, it says state the values of x that must be excluded from the domain. So I can see a square root sign. So what did I say about when I see a square root? What's the important thing about it? It can't be negative. Okay, so to find the values that must be excluded, I'm going to say that x minus 3 has to be greater than or equal to 0. Because that indicates that this expression here would be greater than or equal to 0, which is what has to happen to make sure that the value inside the square root is not negative. Yes, so I'm going to say that this has to be, so I'm going to, would you rather me say less than or equal to 0, or less than 0? Because they are the ones that I'm going to exclude.
Yeah.
Okay. Is everyone else happy with that? Because I'm choosing what's excluded, I'm going to say that the values to exclude are the values where x minus 3 is less than 0. Because they would all be negative. Yes? And for this question, it would be less than, x minus 3 is less than, because x minus 3 is all in that bracket, that square root sign. So we are excluding these values. That means that x has to be, sorry, x is less than 3 would be excluded. I just simply rearrange this. If you had kept x minus 3 has to be greater than or equal to 0, you would have had that x has to be greater than or equal to 3, which means you exclude x is less than 3. Because your domain has to be this. So you would exclude everything else. Yeah. Yeah.
Can you just write that down so it's greater than or equal to 0?
No, you have to do the rewrite. Are we happy with that? Okay.
Also, what's the like line under the
Means or equal to.
that on the other one?
So no, we wouldn't put it on here because if x was equal to 3, then that would be 0, and that's fine because you can have the square root of 0, 0. Okay, but the ones we exclude would be the just less than. Yeah. Okay. Proof comes into practice.